Hey guys, I'm glad you were able to find the video today. Today we're going to be talking about meters and Ohm's law. So there's actually some math involved and you're probably going to need a calculator. So there are two different meters that we look at. I did mention them last time. We have the voltmeter, which is a V in a circle on a circuit diagram, and this measures the voltage. Or what we call the electric potential difference. And then we have the ammeter. And this is an A in a circle. And this measures the current. So voltage is measured in volts, which is represented with the letter V. Current is measured in amps, or the letter A. So the main difference, not only do these measure different things, but how they are set up in a circuit has to be different. A voltmeter is always going to be parallel to what you're measuring. An ammeter is going to be in series. So if I draw a circuit, this one has two cells, a light bulb, and a switch. If we want to measure the number of amps, we have to put it in the circuit. If we want to measure the voltage, how we do it is whatever we want to measure the voltage of, usually that would be the load, so the lamp or resistor, or of the cells. So if we want to do the cells, we have to put it parallel. So it means it can't be on the same circuit, the same loop as whatever you're measuring. So ammeter in series as part of the loop, voltage has to be outside it. For this, if you were actually measuring it in person, what we would do is we'd actually take our two cables, these conducting wires, and we would literally touch it on either side of the cells. So the reason why we have to look at these is because we're going to be looking at Ohm's law, and Ohm's law is the relationship between voltage, current, and resistance. But how your circuit is set up changes how these things are affected. So say we have our circuit here, and we say this is 3 volts, and we say this is 6 amps or 2 amps. So this measures 2 amps. Well, our relationship is V equals IR. So the voltage in the circuit is equal to the current, I is current, times the resistance. You can always do the triangle as well, where you have voltage at the top, I, R at the bottom, and whatever you're looking for, you're going to cover up. say we cover up this one. So R is equal to V divided by I, because this line means divide and this line means multiply. So for this one, if we have V equals IR, and we're looking for R because we have V and we have I, remember that's I. R is going to be V divided by I, which is 3 volts divided by 2 amps, which gives us our resistance. So 3 divided by 2 is 1.5, and the symbol for resistance is actually called ohms, and it looks like that. It takes a little bit of practice to draw it. I know that a lot of people don't like drawing it, but it's just a little bit of practice. So resistance and it is just spelled ohms, O-H-M-S, and the symbol is that. So in a series circuit, this is really easy, but sometimes we don't have in series, sometimes we have in parallel. So what's happening is, as we're going through the circuit, this load is going to use this entire 3 volts as it goes around. If we have more, the combination of all the different ones, so let's do another one. So now we have 3 lamps. If we say this is 10 volts, 5 volts, and let's just say 15 volts. To find out the voltage here, to find out the total voltage of the circuit, all we have to do is add up these 3. 10 volts plus 5 volts plus 15 volts, which gives us 30 volts. So in series, that's how it works. In parallel though, if we had these in series and we said that this one was 10 volts, this would also be 10 volts. What it means is that each of the electrons is picking up 10 volts of energy, and as it travels, it's either going to go through the first way or the other way, but either way, it's going to have 10 volts of energy. Here, it has a total larger number, and as it goes through each, it loses a bit, loses a bit, loses the rest, and has none by the time it gets back to the cells. The same thing happens here, but because it has 2 different pathways, it has to lose everything on each pathway. Current, though, is the complete opposite. If you have a current, if you're measuring a current in series, and we say this is 2 amps, no matter where you measure it, it will be 2 amps. It never changes. But if you did the same thing in parallel, if I measured it out here in, say, what I call the main loop, and this was 6 amps, I could possibly measure it over here and this could be 4 amps. And this could be 2 amps. So kind of like how voltage was on the in series, amps are in parallel. The complete number of amps can change between the different parallel options, but they have to add together to give you the total. The 2 and the 4 have to give you the total of 6. There are 2 questions. The last 2 questions on your worksheet has to do with this. So you just have to look if it's parallel or if it's in series, if you're looking at voltage or if you're looking at current. So voltage in in series, voltage adds up, current stays the same. In parallel, current adds up, but voltage stays the same. So this is also in telling depending on how we have our cells. If you have 2 cells in series, usually one cell typically is 1.5 volts. So if we have 2 cells in series, this is going to be the same as 1.5 plus 1.5, which will give us 3 volts. If we take those same 2 cells and we turn it into parallel, our voltage, because there's the 2 different pathways, it's only picking up 1.5 volts of energy. So it's only going to be going to have a voltage of 1.5. The super important thing about parallel and why we actually, most of your house and most of what you use is set up in parallel. The reason why is if we had a circuit that had 3 light bulbs, let's say, can't forget our cells. Okay, so I have 3 light bulbs. If this light bulb breaks, it closes the circuit down, which means these 2 lights will not light up because this has now created a hole in our circuit. Oops. It's created a hole, and remember, a circuit has to be a closed loop. So with this hole, the circuit actually can't continue. If we had the same 3 cells and 3 cells and 3 light bulbs, but we had the light bulbs in parallel, if this light bulb went out and we ended up having that break in the circuit, if you look, even though there's a break here, the electrons can still travel down and go through this light bulb or this other one. This actually, I'm not sure if you guys would know this or not. So if you have really old Christmas lights, what used to really suck was if you had one light bulb that died, the entire string of lights wouldn't work anymore. and you'd have to systematically go through your entire string of Christmas lights to find out what one bulb was burnt out. Nowadays, they make them so that they're all parallel like this. So if one light bulb on your string of Christmas lights goes out, you can see which light it is, and it won't affect the rest of the string. Okay, so you are going to get questions with V equals IR. You'll also get some questions that are just asking you to draw circuits, setting up either an ammeter or a voltmeter. So remember, ammeter is in the series, as in we could replace that there. Voltmeter will be parallel to whatever you're measuring. You can't just put it over here. That does not work. It has to be on either side of something that you're measuring. So for V equals IR, you could be given something like an appliance has an electric potential difference of 12 volts and a resistance of 6 ohms. What is the current? Okay, so first we have to remember what letter current is, which is our I. So if we're looking for our I, that means we have to do V divided by R. Okay, so our voltage is 12 volts divided by the resistance, which is 6 ohms. 12 divided by 6 gives us 2. And don't forget, current is measured in amperes or amps, which is A. You might also be given a question of an appliance has a resistance of 4 ohms and a current of 6 amps. What is the voltage? Okay, so we look at our triangle, V over I, R. We're looking for V, so that means it's going to be I times R. Our I is going to be 6 amperes times 4 ohms, which is 24 V, which is volts. Okay, so everything in your house is done in parallel just because of the reason why I was talking about up here. You wouldn't want, if you had one light go out in your house, you wouldn't want the rest of the lights to go out. If you had one breaker go, you wouldn't want the rest of the entire house to go pitch black. So most of our houses are actually done up in parallel to make it easier for us. So you have an assignment that is in the folder under physics. It has, I do believe it's only 2 pages long. Most of it is drawing circuits again, with some adding an ammeter or adding a voltmeter, some determining the voltage, and the last 2 questions have to do with the parallel and the in series and how that affects the voltage and the current. I hope you guys are having a great week, and I'll talk to you next week.